Hello friends, my name is Dahat PG and I am working in RBNB College, Srirampur. Today I am going to deliver a lecture on semiconductor devices. This is the first lecture on semiconductor devices. It is in a Maharashtra State Board pattern. Okay, the chapter name is Semiconductor devices. As the name suggests, semiconductor devices means the device which are based on the semiconductor. We know that the semiconductors are the silicon and germanium. After 1930s, the invention of these semiconductor, because of the invention of these semiconductors and the smaller size and reliability of these semiconductors, the wall tubes are vanished and these semiconductors used in a devices. Such a devices are the diode. Okay. Diode and transistors. Okay, when in this chapter we are going to see these two devices and their applications. We have studied the formation of diode in 11th standard, how the junction diode is made. This junction diode or the semiconductor diode is made up with the two extrinsic semiconductors, and which is represented like this. When P region is attached with the N-type, P-type semiconductor is attached with the N-type semiconductor, it constitutes or it makes the diode which has the two electrodes, and symbolically this diode is represented by this triangle and a small line ahead of it. Operation of this diode is also we have seen when this diode is connected in forward bias. In forward bias, when positive is connected to this anode and negative terminal of the battery is connected to the cathode of the diode, it is in a forward bias. Okay, then this diode is in a activation mode. This diode is used as a switch. When it is in a forward bias, it is act as a closed circuit. Okay, or it is in a on mode. When this diode is in a reverse bias, it is in a deactivate mode. It behaves like a open circuit, which is in a off mode. Okay, Using this property of a diode, this semiconductor device is used as a rectifier. In our domestic home, in our offices, we get the AC power supply, which has the form like a sine wave. The nature of the waveform of this AC power which we get in our house, in our offices, is like this. Okay, and the DC power is the direct line. This is the voltage and this is the voltage. When we plot the graph like this against the time, this AC power generation is cost effective as compared to this DC power supply, and even the transmission of this AC power supply is more convenient as compared to this power supply. Okay, in our domestic use, we use the AC power of 230 volts, which has the frequency 50 Hertz. Then conversion of this AC power to the DC power with the help of this PN junction diode is called as the rectification. It is called as the rectification, and the circuit is called as the rectifier circuit. Rectifier circuit. Let us understand this rectification process with the help of the block diagram. Here is the block diagram to understand the rectification, how it is done. Okay, this is the transformer. This is the primary coil of the transformer P1 P2. Here is the mains AC supply of 230 volts AC mains, and which has the 50 Hertz frequency. The secondary of this coil is connected to the rectifier circuit. This rectifier circuit this rectifier circuit consists of the circuit of a diode. We will see it later on. First of all, understand it. What is the rectification with the help of block diagram? This rectifier circuit is again connected to the filter circuit. The next circuit is the filter circuit, and this filter circuit is connected to voltage regulator. And we get the output at this load resistance RL. We get the output at this load resistance RL, which is VO. Okay, this is what the block diagram of the rectifier circuit. At this point we are giving the input transformer. The input at this point is a sinusoidal wave, which is the AC supply. Okay, even at the secondary coil S1 S2, the input waveform is sine wave. Okay, after passing through rectifier circuit, which is a circuit of diode, we get the waveform like this. The wave is flowing here in a bidirectional way, but at this stage, after the rectifier circuit, we get the pulsating output, which is shown in this B diagram. Pulsating output we get here. This pulsating output has some AC component in it. That AC component is known as the ripple. To remove this ripple, one filter circuit is used to remove the filter circuit, remove the ripple factor or the AC component which are in a waveform. We are moving from AC to DC. Remember that we are converting this AC waveform in a DC waveform. Now, how the process takes place? At this stage, after the rectifier circuit, we get the pulsating waveform. Applying this filter circuit, we get the waveform like this. Even at this stage, the output, there is some ripple inside the waveform. Then a voltage regulator is applied after the filter circuit, and we get the output as a pure DC waveform, which is shown in this D. Okay, we get the DC output at the load. Here in a load we can attach any type of devices. Such a rectifier is required in a mobile charger or the TV appliances. We can apply these appliances, charger or TV, in this load area. Okay, in this voltage regulator, we know that we use the regulator for our fan. What it does, it regulates the speed of a fan. Similarly, the desired output voltage we can get by this voltage regulator. If we want a particular voltage at the output, that particular output or desired output voltage, we can get it at this load V0 with the help of this voltage regulator. What does this transformer do? It reduces the AC supply to the desired level, or which level we want it, and even it reduces the chances of a shock. It prevents us from the electric shock. Let us see how the PN junction is used as a rectifier. PN junction diode as a rectifier. We know that in our home we get the AC power supply. The conversion of this AC power into the DC power is called as the rectification. Conversion of AC voltage or the current to the DC voltage or current is called as the rectification. Okay, and the circuit is called as the rectifier circuit. Now there are the two types of the rectifier circuit. First one is the half wave rectifier, and the another one is the full wave rectifier. There are two types of the rectifier circuit. First one is the half wave rectifier and the second one is the full wave rectifier. Let us draw the circuit diagram for the half wave rectifier. In a half wave rectifier, this is the transformer primary, AC mains. This is the primary coil of the transformer, which is represented by P1 and P2, and this is the secondary of the transformer S1, S2. It is connected in series with the diode. The anode is here and this is the cathode, and the next point, cathode, is connected to the secondary of the transformer. Okay, and the output is taken in this point. The load resistance is applied here and output V0 is taken. V output is taken in these 2 points. Here transformer is step up transformer or step down transformer. The transformer is used to reduce the AC supply, and the second thing is this transformer avoid the electric shock to us. It reduces the voltage to the desired level. We can understand this half wave rectifier by showing these waveforms. Okay, this is the waveform we are giving to the input of the diode. Okay, this is the input voltage. Okay. We know that this is the AC supply given to the diode. What happens in a positive half cycle? This diode, when positive is connected in positive half cycle, in this positive half cycle, this diode is in a behave as a closed circuit. This diode is behave like a switch. It is in a activation mode when it is when positive half cycle. During this positive half cycle of the AC power, this diode is in a forward bias and it is in activation mode. It conducts through the circuit and current flows through this diode and we get the desired voltage across this load resistance. In the positive half cycle, diode conducts and we get the waveform at the output, and in the next negative half cycle, this is the negative half cycle of the AC power supply or alternating current, we do this diode is in a off mode, it is in a deactivate mode. It behaves like a open circuit and it do not conduct any voltage or current through the circuit, hence we do not get any type of waveform here. And again, when in AC, in a positive AC cycle, diode D starts to conduct and we get the waveform like this. This is what the waveform we get. This is the rectified output we get. Okay, we can use it for the charging in a charger to charge our mobile, but it takes the time, it has some lacunas, it takes the waveform is not perfectly DC. So for that, this PN junction, another rectifier circuit is used, and that rectifier circuit is the full wave rectifier circuit. Let us see the circuit diagram of the full wave rectifier. This is the second type of rectifier circuit. In full wave rectifier, there is a use of the two diodes. Two diodes are used. Diode 1 diode 1 and diode 2. Here is the anode and here is the cathode of the diode second. This is diode 1, this is diode 2. These diode 2 are connected together. This is the junction, and at this junction load is attached where the output of the voltage is taken, and the next point, another terminal of this load resistance, here is the V output, another terminal of the load resistance is connected to the center tap. Here transformer, center tap transformer is used, and this is grounded. This is the difference between the full wave rectifier. To overcome these things, because we do not get any full wave here, to overcome this difficulty, we get this, we use these two diodes in this manner. When positive half cycle, in the positive half cycle, the diode D1 is in an activation mode and current starts to flow from So this is A point, A P Q R, A P Q R and S. Okay. In activation mode, when D1 is in activation mode, current in a positive half cycle, the output voltage at D1 during this positive half cycle, output voltage at D1, we get the output at here. Current flows through this A, P, Q, R, S. Okay. In the next negative half cycle, output voltage at D2 at negative half cycle comes here, and this D2 becomes the active and current starts to flow in this way. Okay, and D2 starts to conduct. Again, in the next wave cycle, D1 becomes in a forward bias and D2 becomes in a reverse bias, and we get the waveform output at D1. And in negative cycle, this diode D2 becomes in a forward bias. In a activation mode, that diode D2 is in a activation mode, and we get the waveform like this. The total output of this full wave rectifier, we get the output like this. Okay. In such a manner, this output is even pulsating, but there is some advantage of this full wave rectifier over the half wave rectifiers is the rectification takes place in both the cycles. First advantage is of this advantage of the full wave rectifier over the half wave rectifier is, first thing, we get the rectification takes place in both the cycles, in positive half cycle D1 conducts, and in negative half cycle D2 conducts. We get the rectification in both cycles. Second, the efficiency of this full wave rectifier is high as compared to the half wave rectifier. Efficiency of this full wave rectifier is high as compared to the half wave rectifier. And the third thing is the ripple factor in the full wave rectifier is reduced, and the ripple factor in the full wave rectifier is reduced. Okay, in this way we have studied the PN junction as a diode rectifier. The two types of the rectifier, one is the half wave rectifier and the second one is the full rectifier. That's it for today. We will meet in the next part.